Hey guys, we just had a look at a basic review of what complex numbers actually are, and I've just done some worked examples here from your textbook. So we're going to go ahead now and we're going to have a go at some algebra stuff with the complex numbers. So here I've got a question. So again, this has got some worked examples. Excuse me. This has got some worked examples in your textbook if you wanted to have a look at the worked example instead. But I mean, these are pretty simple to go through. So let's run through them real quick. Okay, so if P is equal to 6 minus 2i and Q is equal to negative 3 plus 3i, evaluate each of the following without using a calculator. So great tech-free example for a simple familiar question. Okay, so the first thing that I'm going to do, I'm going to write some information over here, the information I do know, 6 minus 2i, and then Q is equal to negative 3 plus 3i. Okay, so the first question that we have is 2p minus q. So I'm going to multiply everything in here by 2. So 2 lots of 6 take 2i, minus negative 3 plus 3i. So I'm going to expand these brackets and I'm going to distribute this negative to this bracket here as well. So I've got 2 times 6 is 12 minus 4i, negative 3 is going to make plus 3 minus 3i. Then I'm going to go through and I'm going to collect my like terms. So I'm going to collect my numbers and then my real components, and I'm going to collect my imaginary components. So 12 and 3 is going to make 15, and then negative 4i and negative 3i are going to make negative 7i. Okay, let's do another example. So I'll just clear this one and I'll come back. Okay, so the second question that we have here for question B is going to be P times by Q. So now all I'm going to do is I'm just going to pop them in brackets because, I don't know, I always like to just substitute things with brackets. I feel like it makes it easier, first of all, to see what you've substituted in. And also, like, people usually stuff it up when they substitute things in because they don't distribute things correctly or they don't raise things to the correct power. Like, they always miss it. So that's why I like to have everything that I'm substituting in brackets. So I'm going to do the same thing here. So this is going to be 6 take 2i multiplied by negative 3 plus 3i. So let's do this multiplication. 6 times by negative 3 is negative 18. 6 times by 3i is going to be 18i. Negative 2i times negative 3 is going to be positive 6i. And negative 2i times by 3i is going to be negative 6i squared. Now we know that I squared is equal to negative 1. So negative 1 times negative 6 is actually going to make this positive 6. So let's rewrite this. Negative 18 plus 18i plus 6i plus 6. Okay, because remember, a negative times a negative makes a positive. All right, let's collect our real parts and let's collect our imaginary parts. So the real parts are just the numbers. So negative 16 plus 6, negative 18 plus 6 is going to be negative 12. 18 plus 6i is going to be 24i. Okay, so that's the solution for B. All right, I'm going to clear this off and I'll come back and I'll show you the solution for part C. Oh, I deleted my little thing. Whoopsie. So let's just write it from here then. Okay, so I'm going to put some double brackets in. So the first little bracket is going to have this P in here. So what's P equal to again? 6 minus 2i, boop, plus, what was Q? Negative 3 plus 3i, boop, and then close bracket, squared. Okay, so let's simplify this here. Now, if I distribute positive 1 or this plus sign across the bracket, it's not going to change anything. So I'm just going to get rid of those brackets straight away. And what I can do is I can now do 6 minus 3 is going to be 3. And then negative 2i plus 3i is going to make positive I. And we've got to square that. So remember, I mean, we could do this using binomial expansion and using Pascal's triangle because that method is pretty quick. But I mean, we could also just use the FOIL method or the German handshake method. There's like 6,000 different ways to distribute information across a bracket. But this is what we end up with regardless. So 9 plus 3i is going to make 6i plus I squared. And so now let's simplify this. So this is going to become negative 1. Then let's collect the real parts and the imaginary parts. So 9 minus 1 is going to be 8 plus 6i. Okay, let's have a go now. Now these questions here are pretty similar. So you can go ahead and have a go without using a calculator for that if you like. But what I'm going to do is I'm going to have a look at the complex conjugates. So I'll clear this and I'll come back. So just to review what a conjugate actually is, right? When I'm talking about the conjugate partner, effectively I'm talking about the exact same thing. It's just replacing one of the signs. So for example, you've done this before, I would say, with quadratics actually, because if you have a plus b, the conjugate of this particular pair is going to be the same thing. We're just changing this to a minus symbol. Okay, so we've seen this conjugate before, and we actually use this conjugate as part of our difference of two squares rule. So if you're not sure where that comes from, basically we end up cancelling out the a-b terms in the middle. So we've actually used this a few times, but this time we're applying it specifically to complex numbers. But it's the same thing, because all we're going to be doing is we're just going to be writing the same numbers except with the negative sign or the positive sign, depending on what was there originally. So for this first one, e is equal to 14 plus 9i. The conjugate of e, so we're just using this line going over the top here. So see how they've just done this here? Well, you're going to use this line going over the top here, and we're just going to replace the plus with a minus. So this just shows me that it's the conjugate. I don't think I really need to go through the rest of the examples for you, because all you're going to do is you're just going to change this symbol in between. Okay, so this question here is more of a sort of kind of proofy question. So if v is equal to 2 plus 3i and w is equal to 5 minus I, demonstrate that the conjugate of this is going to be equal to the conjugates subtracting like this. Okay, so let's do this little part first. So let's do v take away w first. So v take away w is going to be 2 plus 3i minus 5 minus I. And this is where, you know, putting things in brackets kind of becomes a little bit important, because I want to distribute this negative to both terms. So this is actually going to be 2 minus 5, so that's negative 3. And then negative 1 is just going to make plus I, so 3i plus I is going to make 4i. Okay, so the conjugate of this, so v minus w, is going to be equal to negative 3 minus 4i. Ooh, I should have left myself a little bit more space. Let's get rid of this, shall we? Doop. Okay, so, excuse me. Okay, so let's have a look at this second part of the question now. So we're going to do the v minus w part now. So the conjugate of v is going to be 2 minus 3i minus the conjugate of w is going to be 5 5 plus I, isn't it? Okay, so let's expand this or distribute this negative across the bracket. So 2 minus 5 is going to be negative 3, and then negative I, so 3i, negative 3i minus I is going to make negative 4i. So there we go. We have this side of the equation equal to negative 3 minus 4i, and this side of the equation is also equal to negative 3 minus 4i. Okay, so that's a couple of examples using some conjugates. Do we want to jump in and do an inverse? Do we have enough time? Yep, let's jump in and do an inverse. I'll pause the video here, I'll clear the screen, and we'll jump in and we'll do an inverse. Okay, so question, where'd my pen go? There it is. So question 11a. And again, these have worked examples, so you can jump in and have a look at the textbook if you like. So z to the power of negative 1 is the same as saying 1 over z. So we could rewrite this as 1 over 1 plus I. The issue is, right, or I shouldn't say it's an issue, I should say by convention we don't do crazy stuff in the denominator, okay? The denominator is always going to be like a whole number, it's always going to be a nice value, like it's never going to be anything crazy. You shouldn't have roots or surds or anything in the bottom, you shouldn't have imaginary numbers in the bottom. So what we're going to do is we're going to realize the denominator. Okay, so what do I mean by realize the denominator? I mean, I'm going to make the denominator real. And this is where the conjugates come in, because I'm going to multiply by 1 using the conjugates. So what I mean by that, the conjugate of this is going to be 1 minus I. Now, because I don't actually want to change the value of this, I'm just finding an equivalent fraction. I just want to multiply it by 1. So effectively, I'm just going to times the top by that same value. Now, this divided by this is just going to be 1. So I really want to point out here, I'm not changing the value. I'm just finding an equivalent fraction by multiplying by 1 in the form 1 minus I over 1 minus I. A little bit confusing, I know, but sometimes I think that we do stuff, we don't understand the mechanics of the stuff that we're doing. So just to sort of explain in a little bit more detail. All right, so let's go ahead and let's do this now. So we could actually do this using our difference of two squares rule, except this is imaginary numbers, okay? And so when we have an imaginary square, what does it turn into? -1. So that's how we're going to get rid of this how we're going to get rid of this imaginary part. All right, so 1 times by 1 minus I is just going to be 1 minus I for the numerator. And then this is going to be 1 squared is just 1 minus I squared. Now, remember, this is going to be equal to -1. So effectively what I'm saying is 1 minus I over 1 plus 1. So that's equal to 1 minus I over 2. Now, by convention, generally what we're going to do is we're going to split apart the real and the imaginary part. So I would write this as 1/2 minus half I, like that. I think we should do another example using the inverse. So I'm going to clear this again, and we're going to have a look at question B. Okay, so let's have a look at this question B now. I've lost it. There it is. So Z is equal to 2 minus 6I. And again, we're just trying to find the inverse of that. So that's going to be 1 over Z. So 1 over 2 minus 6I. Okay, so we don't like imaginary things in the denominator. We're going to realize the denominator, and we're going to do that by multiplying by the conjugate. Okay, and what I do to one side, I'm going to do to the other. So effectively all I'm doing, I'm finding an equivalent fraction because I'm only multiplying by 1. All right, so let's do this. So the numerator, I'm going to end up with 2 plus 6I. And then for this, I'm going to just use my difference of two squares rule, and I'm going to get, 4 minus 36I squared, because -6 squared is, -6I times +6I is going to be 36I squared. So let's simplify that now. So the numerator is going to stay the same. The denominator is going to become 4 plus 36. So in other words, 2 plus 6I over 40. And again, we're going to split the real part and the imaginary part. I'm also going to simplify at the same time. So this is going to simplify to 1 over 20 plus 3 over 20I. All right, let's do one more example, I think, and that will be the last one for this realization stuff that we're doing. So Z is equal to -3 plus 2I. So the inverse of Z is going to be 1 over that. So in other words, 1 over -3 plus 2I. I'm going to realize the denominator, and I'm going to do that by multiplying by its conjugate. What I do to the top side, what I do to one side, I'm going to do to the other side. But effectively, remember, all I'm doing, I'm finding an equivalent fraction because I'm multiplying by 1. So then multiplying the numerators, I get -3 minus 2I. And then the denominators, using my difference of two squares rule, -3 and -3 is going to make 9. And then this is going to make -4I squared. Now I'm going to change this into -1, so -4 is going to make +4, so this becomes -3 minus 2I over 13. Then we've got to separate the real parts and the imaginary parts, so we're ending up with -3 over 13 minus 2 over 13I. Okay, so that is really the more sort of complex, the more difficult complex number algebra stuff. The first stuff that we did with Argand diagrams and stuff is pretty basic. I would say this is pretty basic too, to be honest. This would probably be a good example of a simple familiar question, and it might be the top end of like a simple familiar question or like a mid end of the simple familiar questions, but it's not particularly tricky stuff because mostly it's focusing on those algebraic skills. Okay, so at the bottom there, we do have some extra proof stuff. So I will do a separate video with those proofs, and I'll upload that later on today, and I'll show you, I know proof is kind of a crazy thing for us, and I'll show you some more examples on how to do some proofs. All right, guys, see you later.